Okay. Hi everyone. Welcome to the Second Life panel for the VQ and Dialog workshop. I am Ayush, a master's student at Georgia Tech, and I will be moderating this panel today. Before we proceed, a few quick notes. We will be recording this panel, so for those who could not join due to the time zone differences and such, can watch it later. We will be posting the recorded panels on our external website. Everyone except panelists, please keep yourself muted. Panelists, please feel free to speak or interrupt at any point. Everybody, please also keep your videos on if you are comfortable. We encourage audience members to ask questions. This is your opportunity to interact with the speakers. In order to ask a question, please type the question or mention that you have a question in the chat box on this Zoom call, and we will call out your names in a sequential fashion. You can then unmute yourself and ask the question to the panelist. So today we have 5 panelists in this session. All of them are also invited speakers at our workshop. And if you don't know them already and haven't watched their talk already, please watch their talks to learn more about their work. On the panel, we are excited to have Douwe Kiela from Facebook AI Research, who in his talk talked about adversarial natural language inference and hateful memes. Anna Rohrbach from UC Berkeley, who talked about learning to fill in the blanks in video and language. Amanpreet Singh from Facebook AI Research, who talked about supercharging vision in language research using MMF. Ani Kembhavi from Allen Institute for Artificial Intelligence, who talked about grounding situations in images, and Zhou Yu from UC Davis, who talked about augmenting intelligence with multimodal information. So let's get started. To get the ball rolling, I will start with a question from the form that we have sent out to the audience. This question is from Nikhil Shah. So pre-training has been proven efficient in visual linguistic alignments, and because of it, we have been able to improve the performance on downstream tasks. But how efficiently is the transferability of the learned visual linguistic concepts? The paper, Are We Pre-Training It Right, recently released by Aman, focuses on how pre-training on tasks specific to downstream tasks help. So does this show that pre-training is not efficient for learning generalized representations?
Yeah, I would just, it's our paper. So I will just summarize it somewhat before we can start moving on it. So what we realized there is like, if you have like similar domains in the pre-training dataset and the downstream dataset, that helps most compared to like pre-training a dataset that doesn't have anything to do with some downstream tasks. So there is a dataset called MMIMDB, which has descriptions from movies and thumbnail from movies. So you have to like classify them in genres. So we saw that pre-training on Coco doesn't really help on that particular data set. And if you like that do direct training with visual BERT or Wilbert kind of models, they perform better than just doing pre-training and then fine-tuning on those data sets. So we observed overall that if there is a domain similarity between the pre-trained data set as well as the downstream data set, it helps more. And we need to be like very careful with the pre-training design decisions that we take so that you don't end up losing accuracy just by riding on the train that pre-training will always help. So it doesn't always help. We also saw the same thing in hateful memes as well.
Yeah, maybe I can tag onto that. So I think what we found in NLP is that the data that you use for pre-training is very important. So Roberta is basically exactly the same as BERT with some tricks and with better data. So if you can improve the data, sort of the coverage that you get with the data in terms of the domains that you can reliably do inference over, that just improves everything across the board. And so in vision and language, I think we have a problem maybe that we're very restricted to things like COCO and conceptual captions and things like that. And if we have a domain mismatch, then that's a potentially big problem.
I mean, this is not unexpected, right? Because what does pre-training in vision and language do? It allows you to ground nouns, verbs, and adjectives into pixels. So for example, it'll allow you to understand what an object looks like, what does shiny mean, what does on top of look like, etc. And so if the coverage of these concepts and these relationships is different from your downstream task, pre-training is going to take you in a different direction. I think we're at the very beginning of learning how to do pre-training, and these papers that the previous panelists mentioned are actually very interesting. The key is going to be what sorts of data sets can we combine for pre-training, so that there's some sort of regularization, so that pre-training does not take you in one weird direction, which is not helpful, but sort of takes you in general towards the goal of several downstream tasks.
To add on that, so we had an interesting observation in the paper that conceptual captions didn't really help on like most of the downstream tasks, because his captions are a little bit not like they have like noise. So what we did is we used a Coco pre-trained caption generator and used it on CC to generate like better quality captions, and it actually helped us better than just using conceptual captions directly. So we observed that if you have like more data, then you can like do some kind of tricks to like match the domains with the downstream data, and then you can probably improve better on by using large scale of data that's available in the internet or something like that.
Yeah,
Yeah.
all these are very interesting.
Go ahead.
We're gonna go. So another thing that I think I wanted to raise is also about catastrophe forgetting. We're getting like usually we blend different type of data in pre-training, and some of them are maybe more closer to the target domain than others. And we all know, because it's simple gradient descent, they're gonna always prefer the most recently trained data and forget the previous ones. And there are in machine learning active research on how do we have lifelong learning or learning without forgetting. I think it's also something we should be looking into in pre-training. Definitely, we all said more about this kind of domain mismatch, and domain or these kind of specific features are really coming in their varieties of dimensions. In language, definitely we have like a Twitter or Reddit. They all have their own unique features. They all have their unique syntax and vocabulary. They're very different from speech, spoken language, very different from written language. And even in written language, we have literature related, poetry related, or news forms. So there are just domains that are have different type of indexes that you can think about are different from each other. So we also think that having a certain curriculum in the pre-training could potentially be helpful as well. Yes, definitely, because pre-training or you're mostly reading self-supervised learning, your sort of labels coming are free, but your computational resource is not for free. And your bigger your model is, the more power it's going to consume. What is the more green and efficient way to pre-train a model is also, I think, a very important direction.
I guess to add to what everybody has said, in a way, this is not surprising, as we are used to see that sometimes combining even related data sets doesn't necessarily result in sort of complementary effect, and one has to be very, careful about how to design things to actually see improvement. But one other aspect I wanted to bring up is the transfer from images to video that is frequently not successful as well. And especially in video, we might have a limited supervised data. And so I think this is a pretty tricky direction. Sort of how do we use the supervision that we have available in image labeled data sets that are much more extensive? How do we transfer that to video, I think, is non-trivial as well.
Mm-hmm.
So if there's nothing else to add to this conversation, let's go on with the next question. Ashura, do you want to ask your question?
Just to add on like a final note from our paper, so I wouldn't be very pessimistic about the results of that paper. Like pre-training does help like in most of the downstream data set that we have. So some of them are like very out of domain for even for COCO and conceptual captions. I think it's more about data also. So we need to definitely look into like better architectures as well as the better data sources for this. So that's the main takeaway of this paper. Like there maybe we still need to explore more on like pre-training side in vision and language, just other than like taking the same things from NLP and directly applying them to vision and language. That might not work here.
My question was related to this ongoing discussion. It seems like multiple people have been thinking about it. I think probably there are also papers out, I'm not sure, about this question whether pre-training is just a better initialization, or if you are learning something more useful in the sense that if you are actually learning grounding. And there is, I guess there is no probably easy way to evaluate it. Like one way to think about it is like if you could do extensive search over your hyperparameters, and then could you arrive at the same initialization that you are arriving now with pre-training? So if you guys have any thoughts on that.
In theory, you could, but it's very unlikely, right? I don't know. I think sort of the jury is still out on that question. And I think especially on the NLP side of things, actually. So I think if you do multimodal pre-training, then you probably do get some alignment between the different modalities. So you do get some grounding, especially for concepts that are in your data set there. But on the NLP side, there is some evidence that you actually find some sort of linguistic hierarchy in language. So in the bottom layers, you can do things like part of speech understanding and things like that. And then as you go up further in the transformer, then you learn more sophisticated phenomena. And I think for something like that to emerge just as a pre-training thing or just as an initialization thing is very unlikely. So it does seem to help in that case.
I would say that there is the paper that I remember, the paper that you talked about probing BERT. But I wouldn't really say the different layers are learning syntax or semantics. I would say the capture is some sort of like an possible, it could be interpreted as knowledge, but it's not strictly syntax or semantics. And there is certain common sense or that was in some of the pre-training models like Rohrbach or BERT. But it's hard to really conceptualize exactly what it is in a human readable form. It's not certain logical forms. We also have been using Rohrbach fine-tune on other tasks that are involving more common sense. And if we use such model and try to do zero shot in other related domains, but not but still a little bit different, we do see zero shot is getting pretty decent result. So which means that these pre-training model does learn. These pre-training model do learn some of the information from these kind of pre-training data sets. But it's still hard to tell in terms of what do these models learn, and the way that we're using it is strictly just initialization. Potentially with a certain sort of like a permutation, you could potentially find these initialization, but it's hard to say that how do you come into these initialization in the first place, because we know it's impossible to do all these permutations on parameters.
Yeah, so just further on the initialization question. So I mean, one thing maybe not to hijack the discussion, but something that would be interesting here to discuss maybe in terms of zero shot and pre-training is GPT-3. So I was wondering what my other panelists think about that.
It's definitely quite amazing to see that GPT-3 is able to do all these zero-shot problems. But because the model wasn't open sourced, nobody have re-implemented. So I would reserve my opinions on it at the moment.
I agree with that. Without specific details about GPT-3, I wouldn't be able to comment more on that. But this is an interesting direction for a conversation. One way to think of it is that can we pre-train on, like if we get captioning data in specific domains and we pre-train on that captioning data, but we've never learned to answer questions about that domain of data. Can we now answer questions about that domain because we've learned to answer questions in another domain? So for example, just to make things clear, let's say that we have, the model knows how to answer questions about outdoor environments. So we have a large data set of questions about people doing activities in the wild, people doing activities outdoors, driving, climbing, skiing, whatever. And now you have a very, very specific end case. You want to put a camera inside a refrigerator and ask it questions. Do I have milk? How many apples do I have, etc. I don't have a single question here, but I do have images of fridges, the insides of fridges that I can find in Google image search and potentially captions. Can I pre-train on this? And does that knowledge now transfer to the question answering domain? I think such an experiment would probably be, with today's technology, I would say mildly successful. It would still require work, but I believe that pre-training does help you memorize, I'm not going to say learn, but memorize appearances of objects and ground concepts. So I think this might transfer.
Yeah, I would agree on that note as well. We have done work on using meta learning to like you're learning some common information from certain domains and transfer in target domain without any annotations and in data. And it's about how close these domains are. If they're very similar, it's highly likely this is going to happen to be working sort of, not entirely. So it is always depends on the domain that you're working with.
So we also, in this paper, the same paper, we did some kind of experiments to see how well we can do on like few shot learning, or like not exactly few shot learning, but like freezing the pre-trained representation, just fine tuning the classifier to see how generalizable these representations are. So we noticed that the more diverse your like input pre-training data distribution is, something like VQA, which has like questions about various kind of things, health like is more generalizable than just using directly Coco captions kind of pre-training data. So it seems for us, it seemed like the more diverse the pre-training data is more generalizable, and it takes like less time to even fine tune on the particular domains. So we measure that in number of iterations it took to like reach the final fine tune stage. So we noticed that VQA just freeze the whole pre-trained structure and just fine tune the classifier. The models pre-trained on VQA were like much better than Coco and others on VQA and related tasks. So it seems like there are possibilities if we are like very diverse kind of like pre-training data distribution, then it can learn like various kind of stuff around downstream data sets that are very different also.
Mm-hmm.
Yeah, so if there are no further comments, let's go with the next question. So someone has entered on the chat. The question is directed towards Anna, but others feel free to chip in. What makes transfer from images to videos so difficult? Is the bottleneck aggregating temporal context only?
I would argue not only temporal context. So in videos, we're going to be encountering objects sometimes from different viewpoints that we would maybe use to see them in still images. So we had a fun project where we just tried, for instance, referring expression comprehension model trained on Coco applied to videos, and it would be extremely unstable. So like we would have two frames which are very similar, but maybe one is slightly blurrier than the other, or slightly different angle, and these models would just break and would be just like on and off, flickering on these frames. So they are not really meant to be robust to these variations in viewpoint, blur, and just unusual angles. So we would be countering things which happen over time, and of course the temporal context as well. But yeah, I think just what we see and how the objects are manifested in images and video is quite different. And also in my experience, a lot of work that I've done is with movies, which are like realistic movies without any fancy special effects even. But there we see that almost nothing transfers really, and almost nothing works from many sort of strong pre-trained models which come from other domains, both image and video. And some of that is really kind of a mystery to me. There's just something about how things that we manipulate with as humans in these movies, how they are maybe small and just difficult to recognize. Yeah, I guess that's several aspects, but happy to hear other people's thoughts.
Well, I think a lot of the images in image data sets are also taken, have also been chosen to be images that have been taken from good camera angles, showcasing lots of objects at high resolutions, etc. Whereas a lot of the movies, are not focused on objects that are being manipulated by people. A lot of emphasis is given to the dialogue, and so if you have a VQA system or a captioning system that's expected to talk about the dog walking in the background, not too many pixels are dog is probably blurred out, probably in the background, not with the best lighting, and so we're sort of going back to classical computer vision problems when it comes to video. I feel like our image data sets are far more perfect than video data sets, just because video data sets are more, they're from sourced from data that was meant for something else.
I guess I would add to that additional signal, audio, and dialogue is very helpful for us to make sense of what we are seeing in videos, and maybe we're not always capturing that and modeling that in our methods. So even if we don't say something that's like small in the background, but we can hear it makes noise, then we can understand what's going on. So I guess humans can fill in all these blanks, if you will, with all these additional modalities, additional signal.
Okay, so let's move to the next question. Vishwak, do you want to ask a question?
Hey, can you hear me?
Yeah.
Awesome. This question is to Ani, but others, please feel free to chip in as well. So you guys collected the SWIG dataset, which is a dataset containing structured information like entities, nouns, verbs, etc. for images. And I was wondering, how do we actually scale these datasets to millions of images? And just to give you a little more context, like collecting structured information from human annotators is very expensive. But datasets like Conceptual Captions have used all text attributes in HTML and some rules written on top of that to collect the Conceptual Captions dataset, which does scale to millions of images. I was wondering if you foresee any such extensions to datasets like SWIG, which have structured information.
That's a very good question, actually. So I think models that are trained on data sets with a lot of dense annotation typically tend to do better at parsing out information from images, from multimedia. So for example, models that are trained with the Swig data set tend to be quite powerful and directed in their answers. But this is not very scalable. You're absolutely correct. When we would like to go to millions or hundreds of millions of images, we would like to go into sort of self-supervised domains, which is going to have to be parsing data of the internet. So conceptual captions is perhaps one of the first few steps in that direction. Today, what we're doing is we are pre-training on this extremely large amount of unsupervised data or self-supervised data, and then fine-tuning on specific tasks. What hasn't been explored is if you have a little bit of dense data and a lot of noisy free-form data, how can we combine these in interesting ways to still force models to be able to do directed tasks? So I think that's one research direction that has got a little bit of we've seen research in this direction a little bit, but I think I posit that we'll see more in the future.
So if there are no further comments, let's move to the next question. So the question is, are VQA models ready for production? For example, replacing remote users for responding to questions from visually impaired users? If not, is this primarily a data issue or a modeling algorithms issue?
I think I can comment on this one. So they our current VQA models are very good in the settings we generally train them on, like VQA 2.0 or something else. But for blind users specifically, they have questions that require reading text in the images as well, which we are not anywhere close to like good at this point. And if the image is like very good, so we have like tried to deploy something in like an internal demo, and we are seeing like the image is very good, then the VQ model is very like happy to like answer it in a very correct form. But if the image is a little bit distorted or something, not like how Coco clean is like Coco data set, then it has like issues understanding the context, which is usually what how blind users photos look like. And text is one another issue. So I don't think they are quite yet ready or there yet to be deployed to production for any kind of use case. For some specific use case, yes, but not for general use case.
Yeah, I still think it is not really into the production level. Mostly is from the safety issue. Right now we're doing multi-class or whatever question answering. We think like every question is equally important than the others. But in reality, some of the questions, if you answer it wrong, it has certain effects you don't want to see. Like for example, you fail to predict a car coming. So there is not really any like a reality in terms of the usability test on these VQA questions. And there's no safety test on these VQA questions. And also definitely other ethical questions and stuff.
I think it's a little bit of a chicken and egg problem as well. So we've seen that, a lot of models, not just neural networks, but all sorts of production machine learning models, they tend to work really well with a lot of data and a lot of real data. So for example, search engines have gotten much better because they exploit user clicks, right? So it's not just their base search retrieval algorithm, but they sort of use user clicks to improve their results. And so the question is, how do we do this for models like VQA, which are deployed for the blind? We can't sort of deploy a poor model and then just improve, because that has extreme ethical and social concerns that like we just addressed. And so maybe it's a bit of sort of piggybacking on safer solutions and learning from that data. So I really like the VisVis data set because it's a very real data set with a real end case. If we had systems where blind people could, send their photographs, send their questions, and we have seen demos of this sort on Turk, where you send in your question and then you can get an answer. If we actually had these sorts of live systems aiding users, then we would expect that models might get much better by just sort of imitating live data, as opposed to being deployed live and then improving by themselves.
Yeah,
That would be great. Sorry.
So I don't have a lot to add. I just wanted to just briefly say that I think the main issue here is not necessarily modeling or algorithms yet. It's just data. So we just don't have the sort of data that you need in this situation, I think, to actually do something production worthy. And the question is, how do you get that data? And I think there are some good initiatives around that.
There was a discussion about this at the VisVis workshop earlier today. So if you guys, I don't know if they recorded their panel, but hopefully they did. So check it out. But I think one of the other aspects to consider is that the visually impaired folks themselves would maybe think differently about some of these issues, because they might think that any information is valuable and they could try to kind of figure out about some very obvious errors on their own. But given an opportunity to see some of these systems and sort of play with them might be valuable for them even in the present form. But obviously these data sets, many of them were not collected with the visually impaired kind of needs in mind. They were crowdsourced from Turkers and whatnot, or automatically generated question answers. So clearly efforts like VisVis are really important and hopefully can be scaled.
Okay, let's move to the next question. So the question is, regarding video QA, what are your views on few answers like fill in the blanks versus dialogue tasks, especially from a video understanding perspective?
I'm not sure what few answers in this case refers to, because one could frame a VQA task and have sort of an open-ended answering scenario. Or is this just about framing this as classification as opposed to generation, dialogue versus sort of, I'm not quite sure what the distinction here is.
Anshul, if you're there, you should feel free to clarify your original intention.
Can you hear me?
Yes.
So
Yes,
yeah, my question was something like, so for example, I see that some of these data sets, like I think I was checking audio, scene-aware visual dialogue, where you're expected to generate a dialogue, where my understand, so I'm very new to the field, so yeah, just chime in if you feel that something wrong I'm talking about. So I feel that you have to generate an entire question, you have to generate an entire answer, and the fluency and how good the answer looks like also matters. Whereas say in the data set like the fill in the blanks data set, the actual answer matters. So I just wanted to know your views on training for these data sets, where so I want to ensure that the visual part is actually focused on instead of just the language part.
So I guess if I understood correctly, my answer would be, if you're interested in how accurately your model, your multimodal model can, perceive certain concepts in the image or video given a question, then I think fill in the blank and like sort of more standard VQA tasks are pretty appropriate for that. I guess the dialogue really invites more of a conversational interactive setting, where you also want to make sure that your model can communicate with the user. So it's really a different task, and depending on what your use case is, I think both are very, very, very useful.
Thanks.
Yeah, I agree with Anya on that. When you come into dialogues, it is really talking about communicative power. You can understand things, so the machine can understand things perfectly and do classification or do fill in the blank, but trying to communicate in human language with another human is sort of the different task. So that requires, in terms of a pre-trained language model, for example, and grounding informations between language and vision, and also context information tracking, which is a harder task. It's not only understanding, but also language generation.
Okay, let's move to the next question. So, do the panelists have comments on self-supervised learning? It shows strong performance on linear classification on vision, speech, language after unsupervised pre-training.
I mean, I can go first. I think it's the future. And I think everybody in the field sort of knows that we can expect big things to still come from that. It's a bit unclear if it's going to get this all the way. So I think a lot of people have been sort of preaching this. For example, Jan LeCun has been talking about self-supervised learning for a really long time. So I still think we have a lot to explore there, but maybe, for example, in case of language, you also want to have some structural priors, or you want to exploit the fact that language happens in an environment, so it's grounded, and it happens when you use it to communicate to other agents, and that's the sort of stuff where it's maybe less clear how to incorporate that into a self-supervised learning algorithm. So I think we need to not only try to just scale everything up and use more data and do more self-supervised learning, but also think a little bit more about how we can use it in a good way.
I definitely believe self-supervised learning, these previously, all these kind of BERT or related work has been a great improvement in the field. That is actually making something doesn't work into something sort of work, but it still is far away from perfect, and we're still struggling with a lot of things. Because you can really think these kind of self-supervised learning has, it has labels. It was like a coming for free, and you're basically sort of use a lot of these kind of cases, sort of weekly information to help you to have a nicer platform to start. But it's still like for a specific task that these kind of pre-training model, it's just giving you like a 60% or 70%. It's not giving you 90% at the moment. And also we have been really seeing that I think it's still, we are still struggling. I think the breakthrough still has to come from algorithm. If you look at, I would just pick a simple example, like language generation. For example, Facebook has a new model, Blender, that does social conversations. It looks pretty good on surface, but if you look at deeply, there are still problems, because when you talk about language generation, and all the previous like pre-training model is doing MLE, right, maximum likelihood. And MLE is just basically guaranteeing you generating something that is similar, looks similar than your training data. But it doesn't really condition or has any grounded knowledge. So these models would generate things that never exist. It would generate a movie that never had before. So these questions are still fundamentally troublesome. So I still think that pre-training is sort of a platform for us to develop things on top, but it's not solving everything.
Okay, so
sorry, can I just, isn't it a good thing that we can get these systems to just generate movies that they sort of make up on the fly? That's pretty cool, right? And they can do it in like perfect syntax English, which is pretty impressive, I think.
That's interesting, but it can also be dangerous. That could be a deep fake.
Okay, but if the question is about the usefulness of self-supervised learning, I mean, so obviously there are potential downsides to this sort of technology, right? But so why is that a bad thing for self-supervised learning specifically?
I'm not saying like it's a bad thing for self-supervised learning. I'm just saying there are still drawbacks that these models cannot solve.
Okay, next question. I believe visually grounded representation will be very important for both vision and language tasks. What does it take to visually ground the concepts in the language models such as BERT, GPT-3?
I don't want to be the guy who always goes first. So somebody else can go first.
So I can add on this. So I think the question is mostly about still about future, because we still aren't sure like if we are actually grounding the concepts inside what we are training in as visual word or something else. Because from our past experience, we have observed like mass region modeling doesn't work as well as mass language modeling alone. So there are still gaps in how we exactly are pre-training the image side in these models here. Because generally like all these ResNet models have like very wide reception field that even if you mark some of the region, then it still can recover whatever it didn't know. So there's some kind of cheating going on here. So we have like new kind of self-supervised training regimes in vision side, like contrastive learning and those. So we should try to like mix these things with the mass language modeling that is shown to like work well on the NLP side. And I think Douwe has like some very good ideas on how exactly we can do this.
Yeah, I mean, so I think this is a super important question, right? And so the way I think about this is more from an NLP angle, maybe, which is, as Joe just said, there are huge problems still with these BERT models or GPT-3 models. And a lot of the issues here concern like real understanding of language, and grounding is a major factor in that, right? So you can't really just make stuff up on the fly if it has to sort of make sense in your external reality. So I would expect one of the big future breakthroughs of NLP to be an integration with multimodal information where we can actually ground all of these concepts in images or video or other modalities. But so that's more for NLP, and so for vision and language tasks in particular, yeah, so I think there you would just see the gains from having a better language understanding and a better understanding of the relations between the concepts and the world.
Yeah, we also have to see like why like a pre-training loss such as like image text matching, even if we remove them, we don't really see like a very huge drop in like the downstream accuracy. So we still need to understand why these pre-training objectives are not still working well. So it might be on the pre-training architecture side, like how exactly we are doing pre-training. So we still need to look into what losses and what kind of pre-training regimes we are using here.
Yeah, so one question would be just alignment and like learning to ground concepts and map words to objects. But I think there's also maybe a more fundamental notion of model theoretic truth. So a sentence is true or false with respect to a world. So if you think about grounding, very often this happens at the sort of word level, right? Where you want to have a mapping to objects in the world. And I think if you think about language, then you often think about the meaning of a whole sentence. You don't think about words. And so I think that's been relatively unexplored in the field.
My intuition, my experience so far with not just these models, but in general vision language multimodal systems, is that they wouldn't really appropriately learn to ground things unless you either force them or supervise them or sort of encourage them somehow, motivate them that grounding is important. Otherwise, they will just cheat in all possible ways. And so I guess the intuition is that the tasks themselves should either be designed such that prevents cheating, sort of more balanced, or like kind of adversarially designed sets where cheating just is out of question. Or one has to really supervise the grounding itself, which is non-trivial, I guess, in these systems.
Yeah, I totally agree with Anya. A lot of times these multimodal data set, A lot of these models without real grounding, they can do pretty well because you can do majority vote or language model pre-training, some knowledge, ground knowledge base, you can do pretty well. But how can we sort of like twist these models' arms to make it really do the things that we want, really have the compositionality, have the grounding? It's really something I think we should explore more because currently a lot of pre-training models, you can just get them and do fairly well, but sometimes they're not really learning the real grounding.
Yeah, I think there is some ongoing effort in terms of how do we design a more challenging, perhaps adversarial or compositionally novel test splits that would actually show that these models are capable to generalize beyond their in-domain sort of splits.
I think Demos want to say something.
I don't know if it's appropriate to intervene. Just a quick note on visual grounding. I suppose that one way to do that is force it. No, so we actually tried at some point to download the whole of Wikipedia and try to force kind of visual grounding by forcing a network to learn, looking at the image, which kind of topics it would be nice to illustrate. No, and that of course worked reasonably well. You can get some kind of nice visual groundings for images doing this kind of game. The problem is that what do you understand by visual grounding? So is there a single visual representation for every object? Obviously not. Are they reasonably distributed? Obviously not. So what we found out eventually is that it makes no sense to try to map an image to a particular point in your semantic space. You probably want the same kind of image can be expressing a number of different semantic aspects. No, so it's a one-to-many mapping if you want, and it's very, very difficult to model that even if you explicitly try to supervise that, no? as we did this kind of self-supervision. So, well, that's basically it.
I think that's a very interesting point. I would say if there's any solution to that problem, it would be just having orders of magnitude more data. So if you really have lots of data, then you can sort of figure out latent alignment, I think. So Wikipedia is maybe just too small.
Okay, since we are out of time, let's just take the last two questions. So one of them is, generally speaking, which VQA datasets as of now have the biggest differences between human and machine performance, and why? What kinds of visual questions seem to be particularly difficult for current models, either on the image or quotient side?
I think I can speak on this one. So on last year, we released a dataset called Text VQA, and Demos released a complementary dataset that has same concepts called STVQA. And then we saw like a very long stream of similar datasets coming out. And these datasets still have like a huge gap. And what they basically require is that you need to read text in the image to answer the questions that are in those datasets. So something like what is the temperature on the thermometer? So you need to like understand what is you need to read the text and then qualify it as an answer and then predict it as an answer. So the state-of-the-art model in this year's Text VQA challenge is around 46%, and the human accuracy is around 85%. So there is like still a large gap that needs to be covered up. So I think, and other than that, I think the counting questions still have like a very hard time, like the models have hard time to answer the counting questions. And then specifically world knowledge, which is required, which is not in the current any kind of VQA models, like data sets like OKVQA, which require world knowledge, are still like have a very large gap. So there are like multiple factors that are required to make all these like this just a single model that can work on these particular data sets. So like for text VQA, you need a better OCR system as well as the ability to generalize like out of domain words. Like in VQA, we have like a fixed vocabulary, but in text can be anything. So you can't really have a fixed vocabulary. So how do you model a vocabulary that's dynamic? So all these data sets are like the different kind of challenges. And there was a recent survey paper that covers all of these VQA challenges properly. So I would recommend reading that.
We have been organizing the large-scale movie description challenge for a number of years, and that includes also all these like fill-in-the-blank tasks, retrieval tasks, and more recently we looked into how to understand identities of people in video, and so some of them are framed as VQA tasks basically. And so it seems that in our data, in our domain in particular, the gap is pretty large to human performance, and the automatic systems are doing fairly well on stuff that's really common. And then there is this really, it's really long tail distribution in our case. And so the entire tail is kind of where we are struggling. So it's hard to like characterize it beyond just saying that more rare concepts and more rare questions are very challenging. So this is sort of problem that exists, well, not just in VQA.
Just to add on this,
I can't recall.
yeah, you can go ahead.
I can't recall the gap. I was thinking if I could come up with a think of the gap to human performance, but it's quite large.
And just to add on this, even in like a VQA field, like the VQA dataset itself, there is a split called VQA-CP. So it's interesting to also look on that one, which shows that VQA models currently learn a lot of priors that are inside VQA dataset and can't generalize to outer domain splits. So that dataset also has like a large gap at this point. So which shows that these models are very fine-tuned to particular VQA dataset. So we need to also make progress on that dataset to make these VQA models more generalizable.
So not specifically about VQA, but I just wanted to quickly plug my own talk on this workshop. So in my talk, I talk about two data sets that we recently introduced that have a large gap between machine and human performance, just sort of by design. So as Anna mentioned, there's a lot of interest in adversarial data sets, and so adversarial analyze an example of that. And then hateful memes was specifically designed with what we call benign confounders to make it so that you have to be successful in doing multimodal understanding and reasoning if you want to solve this, because otherwise you're going to get fooled by the confounder. So we're hoping that the community will also be interested in those.
Okay, let's take the last question. Arka, do you want to ask a question?
So you can hear me?
Yeah.
So this is again going back to pre-training. So my question is, like, right now you have very strong pre-trained language models like BERT, and there are upcoming models on just pure vision like Moco and Simpler. So are there any efforts, like suppose you train purely on language and suppose you train purely on images or videos or like just pure visual side, and then you provide some few examples, say this object is an apple or something like that. So can you then learn grounding like much more in a data efficient manner, because pure images and pure language can be scraped from like web very easily, but grounding data is still not so easy to obtain, especially rich grounding data quality. Or like kind of what is stopping us from going in that direction? Like,
well, you can think of our current research directions in the community as sort of doing this, right? Because if you look at these visual BERT, VilBERT, sort of family of models, the text sides are typically pre-initialized by BERT, which has been trained using only language data. The vision side of these models is typically initialized with ImageNet pre-trained models. So that's only vision data, even though it's not self-supervised, but it is only vision data. And now we're using multimodal data to complete this pre-training. And it's not working very well with very few examples. You still need a lot of data to get anywhere. So it's a very interesting research direction you're proposing, and I'm saying that I don't think we are there yet.
Yeah, it's quite interesting you say it that way, because in languages, we not only have English, right? We have multiple languages. So we always have these problems that we don't have parallel corpus. How do we translate from one language to the other? So this is a well thought out problem in NLP. A lot of people have been working on these kind of unparalleled language translation. And there are particular algorithms that if you're interested, you can look into to see if it can transfer into language and vision. So in general, one of the things that they do is you can think like one of the simple low-hanging fruit is about back translation. You can translate one language to the other and then translate it back to see if they actually are similar. So you can do similar things in language and vision just to see if it can give you something.
Yeah, I think that's
I believe there is effort on captioning. It's lagging, sorry. There is some work on captioning with little or no paired data. I cannot quite get all the references right now, but if I find now during this call, I will just post them into chat.
I was going to say, I think that what you just mentioned is a really good idea, right? And so there's a lot of work in like few shot and meta learning things that I think you can easily try on this domain that haven't really been tried yet. So more generally, I think the domain is still, or so the question is still sort of out on how to solve this, right? So if you look at some papers that came out, so I have a paper on supervised multimodal by transformers where you can see that actually these work really well if you just do the unimodal pre-training and you don't do any multimodal pre-training on top. So the fact that that's still very competitive is sort of problematic, I think, for the field, because we should be able to do much better if we do multimodal pre-training. And so on hateful memes, for example, the gap between the multimodally pre-trained and the unimodally pre-trained models is very, very small. So yeah, I would encourage you to go for it.
Okay, so if there's nothing else to add to this conversation, let's end the discussion here. And if there are any more questions, please use the comment box on the CVPR website to ask questions to either to the panel or to individual speakers. Thank you all the panelists for the insightful discussions, and thank you to all the participants for joining. We would like to remind everyone that we have a second round of live Q&A session by the challenge winners, challenge host, and the poster spotlight presenters at 12 a.m. Pacific time today. So make sure you don't miss that. And lastly, if you haven't already watched the recorded talks, I would encourage you to do so. There's a lot of exciting stuff. That's all from me for now. Thank you for joining.
Thank you.
Thanks for organizing this.
Thank you.
Happy to follow up in any emails or something. Thank you, organizers.
Bye.